Hi, my name is Dami, and in this video I will show you how to integrate Triton onto your mobile robot, make a map of the floor and localize using only the floor. The pilot package comes with a Triton module, a network cable and a power cable to get you started right away. For this demonstration video we'll mount a Triton to a Jackal robot by ClearPath Robotics that runs Ubuntu 20 and ROS Noetic. You can use the Triton step model to design an interface to mount Triton to your vehicle. It is best mounted as closely as possible to where you need your accuracy, and it's mounted 40 mm off the floor. Triton needs 24 volts and connects to your robot via Ethernet. While Triton is booting, the LEDs will be yellow, and after it's done with booting, they will blink green and purple. Now let's move on to the software integration. First we'll set up a network so your robot can talk to Triton. Triton's IP address is shown on screen, and the last two digits are the last two digits of the serial number, which can be read off the sticker on Triton. Note that the IP settings on Triton can be changed via our graphical user interface that's available for both Ubuntu and Windows. To validate the connection we just made, we simply ping the Triton and see if we get a response. You can easily interact with Triton using our ROS driver. To start, clone the ROS driver and API repositories from our GitLab page to your workspace. Then, just simply follow the README to install the ROS driver. For software version 5.4, we just have to initialize the submodule within the API and then build our workspace. Next, we'll add a Triton link to our robot description. And we can also use the STL provided in the ROS driver to visualize the Triton in RViz. Now we are ready to create a launch file so we can get started with mapping the floor with Triton. For this demo, we assume your robot already has a LiDAR-based localization system, such as AMCL. The Accerion driver also contains a node that can help you with the right transformations between Triton and your robot. We can simply configure this with just a couple of parameters. We are now ready to make a map of the floor. For free navigation we advise to make a grid, but for this virtual line following demo we'll just map a circle. We can simply enable mapping mode on Triton via a ROS service call. Triton LEDs will start to blink blue-purple, which indicates it is mapping the floor. After we completed our route, we stop mapping and can visualize the map we made in RViz. Depending on the use case, Triton can fully replace LiDAR-based localization systems, or exist as an add-on to add more robustness to your system. For this demonstration we will just use Triton for localization. We will simply modify the launch file we made earlier, such that when Triton recognizes the floor, it will update the pose of the robot. We now enable localization mode via a service call, and can see from the white LEDs on Triton that it's recognizing the floor and updating the pose of your robot. You are now ready to use your favorite navigation stack and drive around by just looking at the floor. If you want to increase the accuracy of your robot, contact our sales team via this email address.